this is about the most difficult problem you could see, at least in this class now. Why don't you just tell me? I'll follow your steps. It is weird, right? 2 ln. These are all ln. So here's the thing: is now we've got 3 logarithms. So what are you going to need to do? Yeah, you're going to need to use some of the properties that we learned. So here's the strategy. I mean, we could move all of these logarithms onto one side, and then use product rule and quotient rule and power property all together. But generally, what you would do in a problem like this is, since we have logs on both sides, let's try to make the one logarithm on one side equal the logarithm on the other side. If they equal each other, then what's inside them equals each other. Which property could I use on the left? Product, right? So I could make this the ln of x minus 2 times 2x minus 3. Okay, which property could I use on the right? The power, right? So let's move the 2 inside. ln of x squared. Okay, now we've got the ln of this equals the ln of that. So it must be that this equals that, right? If the logs are equal, then what's inside them must be equal. That's called a one-to-one property. We've kind of used that before when we were solving exponentials. No, actually, we were solving logarithms, where we would get like 2 to the 4x equals 2 to the 6. And we would say, since the bases of the exponentials are the same, it must be the exponents are the same. Same thing. If the logarithms are the same, it must be what's inside the logarithms are the same. So x minus 2 times 2x minus 3 equals x squared. Okay, that's called a one-to-one property, which you'll see more of next year. Okay, now what kind of equation does it look like we have here? It's a quadratic, right? So you have to think, we need to solve this like we solve quadratics, which is generally, first get it in standard form equals 0. So let's FOIL the left to see what that looks like. 2x squared minus 3x minus 4x plus 6. Combine like terms, 2x squared minus 7x plus 6 equals x squared. Now we need 0 on one side. So 2x, subtract x squared. Right, now we have x squared minus 7x plus 6 equals 0. Right, at that point, you've got several ways to solve. You could use quadratic formula, you could graph it, but it's actually a pretty basic factoring problem. What two numbers, their product is 6 and the sum is -7. -6 and -1. Right? So that is x minus 1 times x minus 6 equals 0. And then, because of 0 product property, we know if this product equals 0, then either this factor equals 0 or this factor equals 0. What value of x makes the first factor equal 0? 1, and the second factor, 6. So x equals 1 and 6. Okay, what's the next step? Check, right? So we're going to check now x equals 6 and x equals 1 in the original equation. And what you're going to see is, when I plug in the 6, I get the ln of 6 minus 2 plus ln of 2 times 6 minus 3 equals 2 times the ln of 6, right, which is ln of 4 plus ln of 9 equals, I'm going to pull the 2 inside, so that's the ln of 36. Is that true? That's a product property. ln of 4 times 9 is ln of 36. So that checks, right? Okay, now we check the x equals 1. ln of 1 minus 2 plus ln of 2 times 1 minus 3 equals 2 times the ln of 1. Okay, but this is the ln of negative 1 plus the ln of negative 1 equals 2 ln of 1. Okay, what's wrong with that? You can't take the log of a negative number. So this answer here is extraneous. Right? It's not in the domain. No, you just say extraneous. So that's why logarithms are a little different than exponentials. Remember, the domain of exponentials, all real numbers. So you would never have that issue. You can plug anything into an exponential anyways. It's logarithms that's limited. Normally it's x greater than 0. You know, here we have a trouble with x equals 1, which is greater than 0. But what's inside the logarithm, you know, it's actually an expression, not just x. That's why it's different.